Okay, let's unpack this. Large language models have gone way beyond just being good at generating text.
Oh, absolutely.
Now we're seeing them actually reason through problems, handle all sorts of data, and even uh, use external tools to get things done.
Right.
And this leap in capability has led to something really fascinating, what people are calling LLM-powered agents.
What's truly a shift is moving from these models that could only,
Hmm.
talk
Yeah.
to systems that can now take action for you. We're entering a new era of software, really, with a much higher degree of independence.
Exactly. So for this deep dive, we're going straight to the source, a practical guide that lays out how to actually build these agents.
Hmm.
Our goal today is to really nail down what these agents are all about, figure out when they're the right tool for the job, and, well, understand the core ideas behind building them effectively.
Sort of a foundational understanding.
Yeah, think of this as your fast track to getting a solid grasp on this quickly evolving area.
If we step back and look at the bigger picture, we're seeing a move away from old school automation where every single step has to be pre-programmed.
Right, very rigid.
Agents have the ability to figure out a workflow on their own, more or less, to reach a specific outcome.
Right. So just to be crystal clear, we're not talking about your basic chat bot that answers a quick question,
No, not that.
or an LLM that just generates some text, or even something that tells you if a comment is positive or negative.
Those have their uses, for sure, but they're not these autonomous problem solvers we're diving into today.
Definitely not.
This begs the question, what really makes something an agent? The guide we're looking at outlines two key things.
Okay, what's the first?
First off, an agent uses an LLM as its central brain, right? The command center for managing the entire process.
Okay.
It doesn't just follow instructions like a robot. It makes decisions along the way, figures out when a task is complete, and can even, adjust its course if things don't go as planned.
Ah, so it can self-correct.
To an extent, yeah. And crucially, if it runs into a problem it can't solve, it knows when to raise its hand and say, okay, a human needs to step in here.
That's important, knowing its limits.
Very.
Mm,
The second key part is that an agent can interact with the real world through various tools.
tools.
Yeah, these could be anything from grabbing information out of a database to sending an email. The agent decides which tool to use at each point in the process, but always within the boundaries, the guardrails we've set for it.
Okay, so now we have a picture of what they are,
Oh.
but when should you actually think about building one of these agents? When does this more advanced approach really pay off?
Well, the guide gives a really insightful example here. Looking for fraud in payments.
Oh, okay.
Think about how traditional systems work. They have a set of if-then rules, right? A checklist of things that might indicate fraud.
Pretty static.
Exactly. An agent, on the other hand, can look at the whole situation, understand the context, and pick up on subtle clues that a rigid set of rules might just miss.
Hmm, interesting.
It's like the difference between, I don't know, filling out a form and having an experienced investigator look at all the evidence.
That makes perfect sense.
Mm.
It's about that more nuanced reasoning, especially when things aren't clear-cut.
Yeah.
So what are the specific types of work where an agent would really shine?
The guide highlights three key characteristics of these workflows. First, complex decision-making.
Okay.
If a task involves a lot of judgment calls, deals with exceptions, or requires decisions that depend heavily on the specific situation, like deciding whether to give a refund when a customer has a really unusual issue, an agent can be incredibly effective there.
Got it. So lots of gray areas. What's the second thing to look for?
Second is when you have rules that are a nightmare to keep updated.
Oh, I know those systems.
Right. Think about those systems with tons of complicated rules that become incredibly difficult to manage and are always causing errors.
Yeah.
For example, keeping up with ever-changing vendor security requirements using a purely rule-based system can be a real headache. An agent could potentially adapt to those changes more dynamically.
Ugh, I can totally see that. So fewer rigid rules and more on-the-fly reasoning. Makes sense. And the third characteristic,
The third is when the workflow relies heavily on unstructured data.
like text, emails.
Exactly. If the task involves understanding natural language, like reading customer emails, pulling information from various documents, or having back and forth conversations with people,
Like processing an insurance claim based on submitted photos and descriptions.
perfect example. That's ideal territory for an agent. Think about the potential to unlock insights from all that information that was previously just sitting there, hard to access.
So, okay, to sum that up, if the problem you're trying to solve is pretty straightforward, the rules are clear, and all your information is neatly organized.
Then you probably don't need an agent.
Right. A simpler, more deterministic, direct approach might be just fine. It's all about using the right tool for the right job.
Exactly. Now, let's say you've got a task that really seems like a good fit for an agent.
Yeah.
What are the essential building blocks? What do you need to put one together?
Okay, yeah. The core components,
The guide breaks it down into three core pieces. First, you have the model.
the LLM itself.
Right, the LLM itself, that's the intelligence, the decision-making engine. Then you have the tools.
The things it uses to do stuff.
Exactly. The external functions or APIs that allow the agent to interact with the real world, to actually do things. And finally, you have the instructions.
The rule book, essentially.
Pretty much. The clear guidelines and boundaries that tell the agent how it should behave and what its goals are.
It's almost like thinking of it as a brain, the model. Hands and feet to interact with the world, the tools.
Yeah.
And a clear set of principles and rules to guide its actions, the instructions.
That's a great analogy. And the guide even gives a little peek at how developers are actually putting these together in software, mentioning Python and tools from companies like OpenAI, just to give you a concrete idea of how it works under the hood.
So let's dig a little deeper into each of these, starting with picking the right model. It's not like there's one perfect LLM for every single situation, is there?
Not at all, no. Different models have different strengths. Some are incredibly good at complex reasoning, but might be a bit slower or, more expensive to use.
Right.
Others might be faster and cheaper, but maybe not quite as capable when faced with really intricate problems.
And the guide even suggests that you might want to use different models for different parts of a larger workflow.
Exactly. That's an interesting idea, like using a really powerful, smart model for the tough, critical decisions. But maybe a faster, more efficient one for the more routine steps.
Yeah, that can make a lot of sense. Optimize things.
Precisely. The recommended way to approach this is to start by building a quick prototype using the most capable model available.
Okay, go big first.
Yeah, this helps you see what's even possible and gives you a performance benchmark. Then you can experiment with smaller, less expensive models to see if they can still achieve the desired results acceptably.
Right.
It's all about finding the right balance, really, between accuracy, speed, and cost for your specific needs. You got to test and iterate.
So establish a baseline, see what good looks like, then optimize. Makes sense. Now, what about these tools? How do we actually define what an agent can do?
Tools are what give your agent the ability to take actions in the real world. They essentially act as bridges connecting the LLM to other systems and data.
So APIs mostly.
Mostly APIs, yeah. If another piece of software has an API, a way for other programs to talk to it, then your agent can likely use that as a tool. But the guide also points out a clever solution for older systems that don't have APIs.
Oh, legacy stuff.
Exactly. You can use computer use models. Think of it like teaching the agent to watch a human use a computer program and then mimic those actions.
Wow, that's a really smart workaround. So how should we think about setting up these tools for our agents? Is there a best practice?
Well, the guide emphasizes the importance of having clear and standardized definitions for each tool. Makes sense, right?
Yeah, so everyone knows what it does.
Makes it easier for different agents to use them and understand what they do. Good, clear documentation, thorough testing to make sure they work reliably.
Standard software engineering stuff.
Pretty much. And making sure tools can be reused across different agents are also really important for efficiency and making your life easier in the long run.
Okay, so treat them like well-documented, reusable software components. And what kinds of things can these tools actually do? You mentioned databases, email.
They generally fall into three categories. First, data tools. These allow the agent to get the information it needs.
Like searching stuff.
Yeah, like querying databases, reading documents, searching the web, that kind of thing. Second, action tools. These let the agent actually do things.
Like the email example.
Exactly. Sending emails or texts, updating records in a CRM system, maybe handing off a customer service ticket to a human agent if needed.
Okay. And the third.
The third is interesting, orchestration tools, where agents themselves can act as tools for other agents.
Whoa, agents calling other agents.
Yeah, we'll talk more about this manager pattern a bit later, but that's the basic idea.
Okay, intriguing. The guide mentioned an example of giving a search agent the ability to search the web and also a tool to save the results it finds.
Right, so it's about giving the agent very specific capabilities.
And it also suggests that if you find your agent has a huge number of tools, it might be a good idea to break things down and use multiple agents.
Exactly. It's about keeping things focused and manageable. Too many tools can get confusing, even for an LLM.
Makes sense. Now, let's move on to the third key ingredient, instructions. How do we actually tell these agents what we want them to do and how they should behave?
This seems absolutely critical. You need to give the agent really clear guidance to avoid it going off the rails.
Oh, absolutely. Like clear instructions are essential. The guide highlights that high-quality instructions help reduce any confusion and allow the agent to make better decisions.
Which leads to smoother workflows and fewer mistakes.
Exactly. So, what are some of the best ways to create these effective instructions? Any tips from the guide?
Several key things. First, use any existing documents you have.
Like SOPs.
Yeah, standard operating procedures, customer support scripts, internal policy documents. Those are incredibly valuable for creating routines that an LLM can understand.
So don't reinvent the wheel.
Pretty much. For example, in customer service, a specific set of steps to resolve a common issue could be directly translated into instructions for an agent.
That makes a lot of sense.
Yeah.
Use what you've already got. What else?
Second, prompt agents to break down complex tasks. If you give the agent a long, complicated set of instructions all at once, it can get confusing.
Yeah, overwhelm it.
Right. Breaking the overall goal down into smaller, clearer, more manageable steps helps minimize ambiguity. Third, define very clear actions.
Be specific.
Very specific. Each step in your instructions should correspond to a specific action the agent needs to take or a specific piece of information it needs to produce. Be explicit about what you want it to do, even down to the exact wording of a message it might send.
So no vague instructions. Be very precise about what needs to happen at each stage. Got it.
And fourth, think about and plan for unexpected situations. Edge cases.
Ah, the tricky bits.
Real life isn't always straightforward, right?
Sure.
There are always variations. Think about what might happen if a user doesn't provide all the necessary info or asks a weird question. A well-designed set of instructions will anticipate these common variations and include guidance on how the agent should handle them, perhaps with conditional steps or branches it can take.
Prepare for the curveballs. That's smart. The guide also mentioned that you can even use very advanced models to automatically generate these instructions from your existing documents.
It definitely can. That sounds like it could save a huge amount of time.
It really could. The guide even provides an example of a prompt you could give to a powerful LLM to take, say, a help center article and turn it into a clear, numbered list of instructions that an agent could follow.
Okay, we've got the model, the tools, and the instructions. The building blocks. Now, how do we actually get this agent to execute a whole workflow effectively? That sounds like what's called orchestration.
Exactly, that's the term. And the guide recommends taking an incremental approach here. Don't try to build a massively complex, fully autonomous agent right out of the gate.
Start simple, build up.
Right. So what are the basic ways we can get these agents to work through a task? How do we orchestrate them?
The guide outlines two main approaches: single-agent systems and multi-agent systems.
Okay, let's start with single-agent systems. What does that involve? Simpler, presumably?
Generally, yes. In a single-agent system, you have one LLM that's equipped with all the necessary tools and instructions to handle a complete workflow start to finish.
Okay.
The guide introduces this idea of a run, which is basically a loop where the agent keeps operating until it reaches a defined endpoint.
Like completing the task.
Yeah, or maybe using a final tool, getting to a point where it can directly respond to the user, encountering an error it can't resolve.
Or it's running too long.
Right, or even just reaching a maximum number of steps to prevent it from running indefinitely, like a timeout.
So it just keeps going until the job is done or it hits a roadblock. And the guide mentions something called runner.run. Is that like the go button?
Essentially, yeah, it's how you'd kick off the process in the code. The guide also points out that using prompt templates is a really smart way to manage complexity within a single agent system.
Templates? How so?
Instead of having lots of different sets of instructions for every single situation, you can create one basic, flexible template and then just fill in the specific details for each case dynamically.
Oh, okay.
The example of the call center agent in the guide illustrates this really well.
Yeah.
Think of it like having a basic script.
And then just changing the customer's name and the details of their issue each time.
Exactly. You have a core set of instructions, but you can feed in things like the customer's name, how long they've been a customer, maybe their common complaints, to make the interaction more personalized and effective.
That makes managing things much more streamlined. So when would you start thinking about moving from a single agent to a system with multiple agents? Is there a tipping point?
The guide suggests that it's generally best to try and get as much as you can out of a single agent first.
Keep it simple if possible.
Right. While having multiple agents can help to separate different responsibilities, it definitely adds more complexity to the overall system. You might need to consider splitting things up if a single agent starts to struggle with very intricate logic, lots of if this, then that scenarios.
Additional branches everywhere.
Exactly. Or if it has too many tools that are very similar or overlap in what they do.
Tool confusion.
Yeah. If the instructions become a tangled mess, or if the agent seems confused about which tool to use, that could be a sign to break things down into more specialized agents.
Okay, so if the logic gets too convoluted or the agent has too many similar tools, it might be time to think about a multi-agent setup. Now, what does that actually look like in practice?
Right. In a multi-agent system, you have several different agents working together in a coordinated way to achieve a larger goal. The guide highlights two main patterns that are broadly useful: the manager pattern
Okay.
and the decentralized pattern.
Let's dive into the manager pattern first. What's the idea there? Sounds like there's a boss agent.
Kind of, yeah. In this pattern, you have one central manager agent that oversees a group of more specialized worker agents. The manager agent doesn't lose track of the overall goal or the context.
It keeps the big picture.
Exactly. Instead, it intelligently delegates specific subtasks to the most appropriate specialized agent using those agent as a tool things we mentioned.
Ah, okay, that's where those come in.
And then it gathers the results and puts them all together. It's like having a project manager who coordinates the work of different specialists.
Got it.
The guide gives a good example of a translation agent that acts as a manager. It might get a request to translate something into multiple languages.
Okay.
So the manager agent calls on separate agents that are experts in, say, Spanish, French, and Italian to handle those specific translations.
So the main agent takes the user's request and then uses these other agents as tools to get the translations done, and then it presents the final combined text back to the user.
Precisely. That keeps the overall flow of the task under the control of that one manager agent.
And the guide even includes some example code showing how this kind of setup could work. It mentions something about code-first approaches versus visual tools.
Yeah, it touches on that. While some systems use visual drag-and-drop interfaces to define these workflows, the approach the guide focuses on is more code-based.
More flexible.
Generally, yes. It allows for more dynamic and adaptable workflows without having to predefine every single possibility in a rigid visual diagram. Gives developers more power.
Okay. Now let's take a look at the other main multi-agent pattern,
Mm,
the decentralized pattern. How's that different? No boss.
pretty much.
Yeah.
In a decentralized pattern, you have peer agents that can hand off tasks to each other based on their specific areas of expertise.
Handoff, like passing a baton.
Exactly. It's a one-way transfer of control for that particular subtask. When one agent uses a handoff function, the responsibility for continuing the task immediately shifts to the agent it's handing off to. And all the relevant information about the current state of the conversation or task is also transferred. Keeps the context.
Right.
The guide uses a customer service triage example. An initial agent assesses the user's problem
Figures out what they need.
and then hands it off to either a technical support agent, a sales agent, or an order management agent, depending on the need.
So instead of having a central coordinator making all the decisions, the agents themselves decide who is best suited to handle the next step and pass the task along.
Correct. And once they hand it off, their part in that specific subtask is done, generally.
That seems really useful for things like routing customer inquiries efficiently. Make
Yeah.
sure the right specialist handles it.
Definitely. And again, the guide provides example code to show how this handoff mechanism works. It also mentions that the agent receiving the handoff can sometimes have a way to hand the task back if necessary, so it's not always a dead end.
Good fallback.
Yeah, it allows for a more fluid and dynamic way of working, especially in situations where you want specialized agents to take full ownership of certain parts of a larger process.
Okay, fascinating. So we've talked about how to build these agents, models, tools, instructions, and how to get them to work together via orchestration. But we also need to consider how to keep them safe, reliable, and, aligned with our goals.
Absolutely crucial. That's where the concept of guardrails comes in.
Guardrails sound absolutely essential. We need to make sure these powerful agents are behaving as we intend and not causing any unintended problems. You don't want them going rogue.
No, you definitely don't. The guide emphasizes that well-designed guardrails are essential for managing risks related to things like data privacy and, frankly, protecting your reputation.
Yeah, big time.
It recommends using a layered approach, not just one thing.
Right, defense in depth, combining several different types of specialized guardrails. So not just one single protection, but multiple checks and balances working together. What kinds of guardrails are we talking about?
The guide lists several important types. A relevance classifier helps to ensure that the agent stays focused on the intended topic
Stops it wandering off.
and flags any off-topic requests, like asking your customer service agent about the weather. Then there's a safety classifier designed to detect unsafe inputs.
Like people trying to trick it? Jailbreaks.
Exactly. Jailbreaks, prompt injections, things like that. A PII filter works to prevent the agent from accidentally exposing sensitive personal information. Very important.
Absolutely. Keep that private data private.
Then you have moderation tools, which can flag any harmful or inappropriate content that the agent might generate, hate speech, harassment, etc.
Content filtering.
Right. Tool safeguards allow you to assess the risk level associated with different tools. Maybe sending an email is low risk, but deleting a user account is high risk.
And trigger additional checks for those high-risk actions.
Precisely. You can also implement rules-based protections like good old-fashioned block lists of certain words or limits on the length of inputs, regex patterns.
The deterministic stuff.
Yeah. And finally, output validation to make sure the agent's responses are consistent with your brand voice and style. Don't want it sounding completely off.
Wow. That's a pretty comprehensive set of defenses.
Yeah.
It sounds like you really need to think through all the potential ways things could go wrong. So what's the best way to go about building these guardrails?
Yeah.
Where do you start?
Well, the guide suggests starting by focusing on the most critical areas like data privacy and safety. Get those basics right first.
Table stakes.
Exactly. And then adding more specific guardrails as you encounter real-world examples of things going wrong or edge cases that you hadn't initially considered.
Learn from experience.
Right. And it's really important to continuously refine these guardrails to find the right balance between security and, well, letting the agent actually do its job effectively without too much interference.
Balance is definitely key. You don't want the guardrails to be so strict that the agent can barely function.
That's the trick. The guide mentions that the underlying software, like the agent's SDK they reference, often treats guardrails as a fundamental part of the system. They use a concept called optimistic execution.
Optimistic execution. What's that?
Think of it like giving the agent the benefit of the doubt to do its job, but having these safety checks running constantly in the background.
Ready to pounce.
Sort of, yeah. Ready to immediately step in and raise an exception or halt things if something risky is about to happen. There's an example in the guide of a specific type of check that can act like a tripwire, basically, to catch potential issues early on.
That's a great example of how you can build in proactive checks that go beyond just filtering inputs and outputs.
Definitely. And finally, perhaps most importantly, the guide stresses that it's crucial to plan for situations where a human needs to step in.
The human safety net.
Exactly. These agents aren't intended to be completely autonomous in every single situation, especially early on.
That makes perfect sense. There will always be unusual cases or situations where a human's judgment is just necessary. So what kinds of situations should trigger this human intervention? When do you pull the cord?
The guide points to two main triggers. First, exceeding a certain number of failures.
If it just keeps messing up.
Right. If an agent tries to perform a task multiple times and keeps failing, for example, if it can't understand the customer's request after several attempts, it should escalate the issue to a human. Don't let it spin its wheels forever.
Okay, and the second trigger?
Second, high-risk actions. Any actions that are particularly sensitive maybe can't be undone easily or have significant consequences.
Like deleting data or spending money.
Exactly. Canceling a customer's large order, authorizing a big refund, maybe even committing code changes in a software context. Those should probably require a human to review and approve them, at least until you're very, very confident in the agent's reliability for those specific tasks.
So having those safety nets in place, knowing when to say, okay, a human needs to take over here. That seems like a really responsible way to approach deploying these things.
Absolutely. It's all about building trust in these systems gradually and ensuring a positive, safe experience for everyone, even when things don't go perfectly according to plan.
Well, this has been a truly fascinating deep dive into the world of LLM-powered agents. It's clear that they represent a really significant step forward in how we can automate complex workflows.
Definitely. Giving systems the ability to reason, use tools, and handle multi-step tasks on their own is, well, it's a game changer.
What's really remarkable, I think, is the potential for these systems to move beyond just following rigid rules and actually navigate complex, ambiguous situations to achieve a desired outcome.
That nuance is key.
So, just to quickly recap the key takeaways for everyone listening. If you're thinking about building agents, you'll need capable underlying models, well-defined tools that allow them to interact with the world, clear and effective instructions.
Don't forget orchestration, a strategy for how they work, whether single or multi-agent.
Right. Orchestration and absolutely crucially robust guardrails to keep everything safe and on track.
And the advice is definitely to start small. Build something simple first.
Yeah. Start with a simple project, get feedback from users early on, and then gradually expand your agent's capabilities. Iterate.
That iterative approach is so important. It allows you to learn and adapt as you go, building increasingly sophisticated agents over time based on real-world experience, not just theory.
So here's something to really think about as we wrap up. Consider how the ability to build systems that can independently perform complex workflows might fundamentally change the way various tasks are approached, not just in tech, but in your own work or even in your daily life.
Hmm.
What new possibilities could this unlock when machines can truly act on our behalf with this level of intelligence and autonomy? It's a pretty profound shift in how we can think about getting things done, isn't it?
It really is. Lots to ponder there.